Welcome to this video, the next in our series on 5 random GCSE questions. These are taken from a calculator paper. First question is about standard form. You don't need a calculator for this one. You just need to write 5.248 and then times 10 to the power of 7, because you need to move the point 7 places to get it from the end of the number to between the 5 and the 2 there. Okay, the opposite applies here. You've got the ordinary number and you just need to have 0.0000787. Okay, and you can see that if you move that point 5 places this way, you get back to 7.87. Okay, so 2 very easy questions on standard form there. And the second part is about comparing two numbers. Both are in standard form already. Alice has made that statement, which of course is wrong. And what I'm going to do is this. I'm going to say that the number A, okay, is actually the same as 0.721 times 10 to the power 8. So I can compare it with B, which is also to the with 10 to the power 8, you see. And then I can clearly say that that is less than B, okay, because I'm comparing to these parts here. So I can just say Alice is wrong. Okay, and since 0.721 is less than 5.73. Okay, and that certainly should get you the marks. Next question. An enlargement. Best thing to do here, you need to be very accurate with your pencil and ruler, and you should use pencil for this. I wouldn't draw on this in pen. You can do that in the exam as long as it's bold and clear. So I'm going to put in these ray lines. There's the centre of enlargement, and it's got to be 3.5 times bigger. Okay, so I've got to go at least 3.5 times further away than the enlargement point. Okay, going up here, I'm going to put 1 through here. So for every 1 square I go across, I'm going across 2, you see, like that. Okay, 1 across, 2 up, 1 across, 2 up, right up to there. Okay, and then for this one, it looks like I'm going up at exactly 45-degree angle. Yes, so that's quite easy to extend that there. Okay, now all I have to do is go the correct distance away from the centre of enlargement. So 3.5. So and there it's 1 away, so I just need to go to 3.5. So this is actually quite easy because it's already set up for me. That will therefore have to go up to there. This will come across to here. Okay, and the hypotenuse of the triangle will simply run from there to there. Okay, and I've answered the question completely. Okay, next question. This is about snakes and the lengths of them in centimetres. Okay, and we've got to put that information on a box plot. So this is a stem and leaf diagram. There's 27 snakes. We need to find the median and the lower and upper quartiles for the box plot. Well, when you've got 27, it's a nice number to work with. You add 1, you get 28. The median is the 14th one. Okay, so the median is going to be that's 4, that takes you up to 9, 10, 11, 12, 13, 14. So that's the median. The lower quartile is therefore going to be the 7th one, 1, 2, 3, 4, 5, 6, 7. And the upper quartile is going to be the 21st one. Okay, and that will take us to this one here. Okay, so we just need to make a note of those 5 numbers. The first one is the lower quartile, which is the lowest number rather, which is 171. Okay, just use the key to understand what this means, 171. Then the lower quartile is 187. Okay, the median is 196. The upper quartile is 207. And the largest number is 217. Okay, now it's very important that you plot these accurately. You can't be one square out because there's no reason to be. You can and should get them exactly right. Okay, so you put a little line at the two ends, what we call the ends of the whiskers, and that's at 217 here. Okay, so that's the first thing I would do. Then I would do the box. So the box starts at 187, which is that one there. Now, it doesn't matter how high the box is. I tend to make it about 3 squares like that. Okay, but it is important that you have the correct position across. So I've got 187, 196 is here. Okay, so just get that in the right place. And that goes down to there. And then let's try that again. So 196 goes about there. And then we've got 207, which is here. Okay, and then you just make your box around those 3 lines. So there's the top of the box. And then we've got the 2 whiskers there and there. Okay, and that's the information from the stem and leaf transferred to the box plot. Next question. Okay, in this next question we have to estimate the speed of the cyclist in meters per second. Now the speed is the distance divided by the time, which is the gradient of that line, and we need to do it at 5 seconds. So looking at the curve, we go to 5 seconds there, we go up to that point and we try and draw a straight line that touches the curve at that point but doesn't cross it, so it matches the gradient. It's quite a tricky thing to do, and it's going to look something like this, okay, in this particular graph. So let's have a look what that looks like. So it's something like this, okay, and what you do is extend that line to a convenient point on usually at the ends of the grid, and then work out the gradient of that triangle created. So you can see that the gradient of this triangle is made of the height, which is 17.5, okay, divided by the distance across the bottom, and that's running from 9 down to 2.4. Okay, so it's 9 minus 2.4. And when you put that on the calculator, that comes out at 2.65 to 3 significant figures. 2.65 meters per second. Okay, you can either write it as ms to the -1, or as they've done here, meters per second, and that's 3 significant figures. It doesn't ask you for any particular degree of accuracy, but that's normally what we would do there. Okay, and they'll allow quite a range of answers because of the accuracy of drawing that tangent. Okay, next question. And this one is going to use the cosine and sine rules. Okay, and you've just got to be really careful here. Make sure you show all your working. It says that there. It's 5-mark question. So what are we going to do? Well, we've got to find the length of the line DC, which is this bit here. Okay, now this won't be drawn to scale, so there's no measuring or anything involved. This has got to be properly calculated. Okay, and we need to first of all look back at the whole thing, and I can see a triangle with 3 known sides. Okay, but we have an unknown angle here, which I'm going to call theta. Okay, and we know that this angle here, if you read the information it's giving us here, is 3/10 of theta. Okay, so 0.3 times theta. And that's the angle in there. Okay, so what I'm going to do first is use the cosine rule to find what theta is. Because if I know 3 sides and I need to find an angle in that triangle, I can use the cosine rule. So I'm going to start by stating the cosine rule in the normal order of things, okay, which is that 4.4 squared, that's the side opposite theta, is equal to 7.1 squared plus 7.2 squared, okay, minus 2 times the same 2 numbers that you've just written down, okay, times the cosine of the angle between them, which is theta. So theta is the angle between those 2 sides, you see, 7.1 and 7.2. Now, we could rearrange that in several different ways, but the best thing to do is to take the 4.4 squared from this side and add the 2 times 7.1 times 7.2 cos theta to this side. So you end up with this. You end up with 7.1 squared. Okay, plus 7.2 squared minus 4.4 squared. Okay, now if you divide all that by 2 times 7.1 times 7.2, then that's a rearrangement that will give you the value of cos theta. Okay, and cos theta, if you put that on the calculator, comes out to be exactly 921 over 1136. 921 over 1136. Okay, so what I'm going to do here is work out the value of theta, but use it to at least 4 significant figures, because the final answer is going to be in 3. So always work to more accuracy than you need. So if you put shift cos that fraction into the calculator, make sure it's in degrees. Okay, you will find that it comes out to be 35.83176. 35 point, and I'm just going to go 83, and it goes on after that, but that's enough, okay, to use with reasonable accuracy. Now I can use the sine rule, okay, so if I show you how that would work, so the length DC over the sine of this angle, okay, is going to be the same as the length of, let's do this in a different color, it'll be the same as the length AC, okay, over the sine of this angle. Okay, that's how the sine rule would work. So what I can do, and I can say that this angle here that I've shown in green is equal to 180 minus that. Okay, because that's a triangle there, you see. So what I'm going to do now is say that exactly that, really. So DC over sine 0.3 times that. So DC, okay, over the sine of 0.3 times 35.83. Okay, I need brackets around that, and I need my fraction line in there. And that is equal to 7.2, which is the length AC, over, and it's going to be the sine of this green angle here. Okay, and that is the sine of 180 minus, well, if I'm taking away theta and 0.3 theta, then I'm taking away 1.3 theta. So it's 1.3 times 35.83. Okay, so if we just rearrange this, then we can find what the length DC is. So what I'm going to do is just take a copy of this, take it down below. All right, so that's going to be there. And what I'm going to do is say that DC is that, okay, DC is equal to this thing at the bottom, okay, but I'm going to move the 7.2 along, and I'm going to put it here, and next to it I'm going to put the denominator of this, which is this, okay, next to it there. So basically all I've done is taken the denominator of that, multiplied it by 7.2 on the numerator of this, and that will give me the length DC. Put that on the calculator and you do indeed get the length DC, which is 1.848, okay, etc. But you say that's equal to 1.85 centimeters to 3 significant figures. Okay, and that is the correct answer to that question. And that's the end of those 5 GCSE questions.